Hey, what's going on, guys? GoMonkeyGames here. Yesterday, I've been watching these guys, TwoSetViolin, which is not really related to web scraping at all, but I've taken an absolutely incredible word from these guys, and this word is sacrilegious. And this is the very first word in the title of this video, so I just wanted to give these guys the credit. Probably they don't really need it, but still. So I'd like to welcome you all, guys, to Sacrilegious Web Scraping Challenge provided by one of my subscribers whose name is Andy. And Andy has found an absolutely fantastic, absolutely sacrilegious, the most sacrilegious ever web scraping challenge I've ever seen in my life, at least. So if you're interested in having a look what the challenge is, buckle up and we begin. So let me just close this unnecessary tabs here, and ta-da! This is the site we're supposed to be scraping. So, you know, like at the first, at a glance, it doesn't really seem to be that weird. You know, like, you might wonder, it's not really that difficult to scrape this description followed by the selling price and the retail price and the image URL if possible. And you might be wondering, like, what the hell is going on here? Like, what kind of challenge is this? But if you have a look at the source code, well, first let's try to inspect the element, and here the disaster is actually kind of starts. So the very first thing to consider here that this data rows don't really have any parent elements to mention or to extract data from, but this is the least evil, to say at least, to be honest. And the other problem is the order how this data is presented on the site is way different compared to the order of how this data is presented in the HTML document. So let me just try to demonstrate you this. So you see, like, if seems like I'm going through the very first elements, but you see, like, the first element is nobody knows where is that. The second element is actually 1, 2, 3, 4, 5 is the sixth one, and then it goes seemingly absolutely randomly. Also, we see that the class names for descriptions here and for column names and for the prices is all about the same. So, you know, like, even if we would try to so we can actually extract all the data, but there is no straightforward solution for mapping this sort of a particular prices to this kind of descriptions. So it seems like it's going absolutely malformed. And you know, like, I also did a little more thin here. So what I've just described here might not be that that clear. So let me just try to invoke my scrapy shell. So this is the solution, by the way. And also, well, before I will start diving into the code and showing you some tricks that would give a clue, you know, how I in particular did solve this. I really encourage you guys to pause the video and try to grab this sort of a URL. I will put the link in the description below this video, and you just try to extract the description, selling price, retail price, and the corresponding image URL. And I bet you will face an incredible issues while doing that. And you know, like, it took me for about 2 days only to find a proper way of how to approach in order to actually solve this, because during these 2 days I thought this is absolutely impossible. So the further part of this video will be containing spoilers regarding the solution of how to solve this sort of a challenge. So if you're interested to solve it, just pause the video and try to grab the URL, try to extract the data stored to CSV file, and well, if I were to show you how my script works, it would be a spoiler already. So just trust me that it does produce the valid CSV file that contains all the data being right over in here, and I will demonstrate this just right in a moment. So for those who really want to try this yourself, please go open your Python and just try to write some code to extract data. For others who either already did this or is not going to be doing this but just want to enjoy the show, just sit back and we continue, basically. So I just want, so here is my scrapy shell, so let me just try to, here's my terminal, let me just try to open the scrapy shell, and, well, it would be better to open the scrapy shell in my desktop to show you this better. So, just open terminal here, and scrapy shell, just try to paste this stuff in. And so do we have the response? Yeah, perfect. So I just want to store this file, so let's call this response htm, and I want to write the file stream and write response.text. Okay, here is our response. We don't need this console for a while. And I just want to open this with my text editor and show you a little trick. So here we got the CSS stylings, which is the clue to the solution of this sort of a challenge, believe it or not. So I just want to get rid of this page down. Where's my page down? I just want to get rid of the CSS stylings and show you how the document looks like without this CSS stylings, and you would be absolutely overwhelmed after realizing how sacrilegious this site is made, actually. And this is the most sacrilegious anti-scraping measure I've ever seen and encountered in my web scraping career. So okay, just hold on a sec here where the style ends. So I just delete this stylings, and I can now close my editor and just try to open this within the browser. And this is how the HTML document layout looks like without those without those CSS stylings. So you see, like, the order, first the order. So we got this Yamaha NS and all this stuff, and it's not right over in here. So if you just try to search for this sort of a speaker right over in here, it appears to be, oh my god. It appears to be somewhere right over in here, which is absolutely weird, right? And therefore it goes even worse. So we got this prices, which you have no idea that this price regards to what. This price regards to the very first element, but not even to this one. So it seems absolutely impossible to understand of how in particular, how the hell they're supposed to map these prices. Even though we don't even know which price is the selling price and which price is the retail price, because the classes are all about the same. So how the hell is supposed to be mapping this data? It seems like absolutely impossible. So you just have a look at this HTML document layout to realize how sacrilegious this is, basically. But this can be scraped and can be mapped, believe it or not. And the key thing here is the CSS stylings. So I just want to show you one more little thing here. So you see, like, we got this particular class names, and don't try to understand the difference between, say, this gear 1, 2, 3, blah blah blah, and all this stuff, and this generated stuff. So it doesn't really matter that much. So we just have a look at the source code of this document and the CSS stylings in particular. We would see that every single element with this sort of a class has an absolute position, believe it or not, absolute position in pixels. Can you believe this, guys? This is absolutely amazing. And this sort of a positions, so, you know, like, every single element is visually sticking to the particular coordinate in pixels on the target site. So this sort of a point right here, right here, right here. And now attention please. So the idea of how did I manage to scrape this sort of a data. I did extract all the top coordinates available right over in this style tag, and then I put them into ascending order. So from the most little to the biggest one, and that helped me to actually get the order of these items just like they are presented on this site. And then I use the index offsets to map this sort of a selling price and retail price to the particular description, and same with its image URLs. And you know, like, it's not really that difficult from the web scraping perspective. It's incredibly hard from the debugging perspective and from the fine-tuning perspective, because you really need to be really precise in order to make all this data match, and I've spent really lots of time doing this. So I'm not going to be walking through the entire process of creating this sort of a scraper. I will just walk through the source code, but before I will start walking through the source code, first I would like to demonstrate you the idea of getting this, of parsing this CSS stylings, right, and then getting this top keys, so the pixel offsets, so how many pixels we need to stand out of the top of the document, and also how we can map this sort of a offset to the particular class name, which would be the very clue for the further mapping of the data being presented on this site. So now let me just go to my current working directory containing the challenge file and open, I just want to open the terminal here. Okay, and I just want to invoke my scrapy shell, even though the challenge itself is done within with request and beautiful, so just with the simplicity, so to cover the more audience, so try to make as many people as possible to follow this tutorial, because it's way easier to install beautiful soup and requests rather than scrapy framework. Okay, so I just want to copy this sort of URL, and let's fetch this. And now we need to say response CSS. We're looking for the style tag, the only one here, and we want to extract the text out of it and get one. So here is our here is the content of our style tag. So from now on we can we actually want to split this by, and let's have a look at the structure. So we got this closing curly braces followed by the new line, and this is an appropriate characters to split this entire string by. So let's have this closing and new line fade followed after. So from now on we can use the list comprehension or to loop over this item. So I can say for item in this list, and I just want to print the item first. So here we got our items, and now we don't really need all of them. We just we only need those that contain this this word, page use demo and also contains stop inside. So here we can say if this guy in item and top property also in item. So hit enter again. Now we have really kind of less elements here already available, and now we would be doing two things. So the first thing, we would extract all the top elements and sort them in the ascending order, and then we will create we will map this top coordinates to our class names. So yeah, I'll just make this within the console, and later on I will switch to walking through the code, because otherwise it would be not that easy to understand like what's going on within the code. So the very first thing to consider, so let's first let's print them, and then we would be storing this guy. So item dot I want to split, just hold on a second, I already forgot how I done this. Split by top, and I want the very last element, and then I want to split by pixels followed by the semicolon and the very first element. Okay, yeah, so here we got a list of our top coordinates being extracted, but there is one more little thing to consider here. So first we want to convert them to integers. Okay, so make sure that it is possible. Okay, and now we don't really want to print anything here, so just let me get rid of the print statements, and here I call this variable called tops for it's the list of top coordinates. So tops, now we can see this tops here, but you see like the order is not that great, so we need to put them into ascending order. So in order to do this, I can say simply tops.sort, and then try to see the tops again, and you see like now we start from the very lowest value to the very highest one, and this order represents the exact order of how the data referenced by this class names is about to be sticking on the target page. So the layout relies on this sort of an order here, because this is the last this is look only how many pixels. Let's see in particular, so 39. Well, I'm not sure 39 from where exactly, but let's say this is 39. Okay, and then we got this 46, 90. So this is so from here to here it's 46, from here to here it's kind of 90, and so on and so on and so on. So that's the way to find the proper order of these descriptions, and also it serves as the proper order for our selling price and retail price, and also for the image URLs as well. So yeah, what next? So the next thing to consider, now we want to know what kind of class corresponds to the given value of the top coordinate. And in order to do this, we need to do the following stuff here. So now I just want, yeah, let me just try to get back right over in here, and I don't want to, well, I will still need to convert them to integers, but first, well, I just want to import JSON to print this sort of a dictionary, and here, so this would be called top coordinate, and okay, and bring it comes over ends here. Okay, now probably I don't even need JSON, at least for a while. Yeah, let me just, yeah, that's avoid complications. I don't really need this. So here we got our top coordinates, and also we need to extract our class. So here I say class, and we say item.split, and now we're splitting this by the opening curly braces, and we need to strip the first element. This dot is not essential, and the very last space is not essential as well, and then we would be able to use this sort of a class as a selector, as the HTML or sorry, as a CSS selector to extract the particular corresponding textual data from using this sort of a selector. Okay, so I'm splitting this by the curly braces, and I want the very first element, and also I want to skip the first and the very last characters of the first item, the first word, and to skip the very first and the very last characters there. So now you see like we got this mapping, so we got this class and the particular corresponding class, and then the corresponding coordinate. So from now on, if we loop over these classes, and if we find the matching corresponding sort of a class, we can already try to extract the particular data that is appearing right over in the scope of the div with this sort of a class. So this is it for the opening part, and now let me just, so what I've just shown is kind of the core ideas of the approach I've used in order to solve this, and I need to say that this approach is quite a bit pretty slow, and probably there is a way faster solution for this, but nevertheless. So let me just actually exit my my scrapy shell and get back to the code. So from now on, I can already walk through the code with you guys to show how exactly it works. So let's quickly search. So just importing some packages, making requests, parsing the content, extracting the content of the style tag. Okay, with the exclamation mark, because this is the core concept here. And then what I've just been talking about. So we did extract our top coordinates, and we call this tops, and we just store this within the tops coordinates. Then we store this with the ascending order, and then we just extract the coordinates that maps the particular top absolute coordinate in pixels to the given class. Okay, and then we're just creating the raw data, or data raw as it's called here, list to be appending items to. So, and here please pay attention. So this is the most essential part of the entire data extraction logic begins here. So first we need to loop over all the elements within this top coordinate. So from the lowest to the highest values there, and within this loop we're looping over all the coordinates as well. And in that case, if we match if the top is equal actually to the value of top within the dictionary representing the coordinates, in this case we get a match. So we get the exact match of the class or the data that is staying behind this class, that is located in absolutely particular top in the particular offset in pixels from the top of the document. So in here we're just using the selector. Well, here I'm using beautiful soup, but it could have been scrapy as well. So I'm using the class. So entry.class is the class. I'm referencing the content by. So I'm extracting the images that does stick to the current given top coordinate amount of pixels, and I'm doing literally the same with the textual data that is located within the div tag. So we're searching for the divs with the classes that kind of corresponds to the given coordinate, and we append both. So we do append this image URLs, and we do append this sort of a textual data as well. And I will now show you how this looks within the console when it works. So, well, probably I'm not gonna be actually running this to the very end first. I just want to show you this concept, like how the output is gonna look like. So Python challenge, this is it. So you see, like here, what are we doing? So we don't really need this very first, guys. We would be slicing them later on, but we got the image URL, and we got the very first, believe it or not, description. You see, like this Karma Elegance 7th floor standards, blah blah blah. So this is kind of it, standards and all this stuff. And then we get, well, for some reason the data is being duplicated, but that doesn't really matter that much. So we got so here, say we got this selling price, and then we got the retail price. For other cases, when it's kind of different, you know, like, so selling price is always less than the retail price, and that's the way how to distinguish them. So how to shuffle them back later on. Okay, so nevertheless, we got the data that corresponds to a given row being appended in a bulk mode, let's say. So we got this URL, then the description, then some pricings, and then we get another one, another description, yeah. And the URL might be appended from not always from the very before. It not always goes before the description. It might go after, it might goes both before and after in some cases. So what we need to distinguish here, we need to make sure that the current element within the raw data we're currently looking at is actually a description, and the further code actually shows how exactly this is about to be done. So we're looping over the elements within the raw data list, so just to get an idea of how the element looks like. So this is the first element, this is another element, this is another element, another element, now this is another element, now this is another element, and so on and so on. So just, I hope this is clear. And as far as we're hitting next element, we have an options like to distinguish between the data types. So the first thing, how I'm distinguishing these guys here. So I say if the length of the current given element is more than 10, it's definitely not a price, because it's less than 10, less than 10, less than 10, less than 10, right? So the data that more than 10 is either this sort of a description or the URL. So how to distinguish between the description and the URL? And I say here like, and HTTP not in the current index. So we make sure that it's not a URL, but we just make sure that this is exactly the description, right? So, and then we say if we have the HTTP, if we don't have the HTTP in the next element followed by the current description. In this case, the offset is equal to 1, and we use this offset to get the pricings respectively. But sometimes it might happen that after the description, so like say right over in here, we don't have, so the second element, so index plus 1 would be called, it's not a URL, right? So in this case we just set the offset equals to 1. But in case if we have, say, this sort of a URL followed after the description, in this case we need to set the offset equals to 2, because that's the exact offset we need to add to the current index in order to get the data that regards to pricings. Okay, so now we're trying to pick up the prices. So where we might be looking for the whatever next element, and we're just so how to find the next elements, because at this moment within this loop we're currently on the description, because this sort of a condition allows us to hit exactly the description. So we're just adding the offset to our index, and if there we get the length of the data that is less than 10, and if we just add the offset and 1 and plus 1 more after offset, so this is offset and this is offset plus 1. So just to make sure where my what is that plus 1 means. So initially I was doing like plus 1, index plus 1 and index plus 2, but that was before I did actually implement the extraction of the image URLs. But after I've implemented the extraction of the image URLs, I needed to use the variable offset instead of fixed plus 1 and plus 2 index addition there. So here I'm just checking if the length of the elements followed by the current one and the length of the element followed by the element followed by this one is less than 10 actually. So in this case we can conclude that this element regards to price, and here we're trying to actually map our data. So this features variable represents the single row on the target website, so it contains the description, selling price, retail price, and the image URL. So the description is the current stuff that we get there, so raw data indexed by the index, and then we got this selling price would be index plus offset, and retail price index plus offset plus 1, and the image URL might be either one URL or 2 URLs, and for a while we just leave it empty. And then we say, then we're trying to check the index minus 1 and index plus 1 elements, because these are the only places, this seems to be the only places where the image URL might have occurred, even though I don't claim that it doesn't have any bugs or issues, so I could be wrong, but just for the, say, 99% of cases, because, you know, like, I didn't get paid for this, so it's still, I really went way too precise in solving this challenge. So well, I don't claim that it doesn't really contain any bugs at all, but still, like, it's the assumption that is quite pretty enough here in order to say that this works kind of this like. So we're checking for the elements, one before the description and one after the description. So let me just show you this. So say this one is one after the description, and say this one is one before the description. And there are some cases, well, I dropped this too early, but there are some cases when we have both. So the one after the description and the one before the description. In that case, this goes in the cases when we have not the only image, but if we have a couple of images, but we don't really have more than 2 images on this side, which is quite pretty nice as well. So in this case, we're trying to append, so if we're finding an HTTP characters within the element, then in that case we just append this element to the image URLs list within the features dictionary. So, and that's the reason how we append the image URLs basically. And after all, we just append all this kind of features to our data output data list. So this is it, but it's not really that it, because after we did this, still there are some issues related to the prices of selling and retail prices being shuffled, being malformed a bit. So and here are some cases I'm taking care of. So we might occur that selling price is not available and retail price is always available. So if the selling or on the contrary, I don't remember. Yeah, selling price is always available, but the retail price might not be always available. In this case, so by default, it did place, for some reason, it did place the selling price to the column of the retail prices. So just to fix that and to put this back, I say, so if within these prices we have an empty element, we just need to shuffle them so the selling price becomes the retail price and the retail price becomes an empty element, just like the make move function in chess programming, believe it or not. When I get a pawn on a given on the target square, and then we're putting this pawn to the in the source square, and then we put in this pawn to the target square, and then we just erasing the target the source square, and it seems like the pawn has just moved from, say, e4 to e2 from e2 to e4, so things like that. So this is quite a pretty similar technique, and like chess programming background really helps me a lot here. So the next thing to consider, we got this guys like call, solve, and in-store being shuffled. So for some reason, from time to time, he considers the retail price to be call, or sold, or in store. So while the selling price is actually some weird numbers too big. So we just shuffle them back as well. And also there might be some cases, it's right over in here, when we get the selling price is bigger than the retail price, which can't be true. I don't know why really, but at least for this site, first I did check that manually, so we always have the selling price less than the retail price. So in any case, if we encounter the situation where the retail price is bigger than the selling price, we just need to shuffle them back. So this is kind of it regarding the fixing price shuffles there, and this is it basically. So the very last thing at the end of the year is just to write this, just to print the data to screen in pre-printed JSON format, and just to write the CSV file. So this is it for walking through this code, and from now on I just want to demonstrate you guys how in particular the output file is working, because until this time you didn't really, you cannot kind of believe me that this kind of works. So I just want to show you it really takes quite a bit of time to complete, and probably there is a faster way of doing this. So if you would have find a better, a faster way of extracting data from this site, I would really appreciate if you share your solution in the commentaries below this video. Okay, so we got our data being scraped, and here is our CSV file. So let's try to open this up, and okay, and now we would be comparing just a couple of things here. So first, yeah, I just don't really need this stuff anymore. So first, I would like to compare this, the order of description. So we got this Karma Elegance Floor Standards, Karma Elegance Floor Standards, then Revel Ultima 2 Voice to Center Channel Speaker. We got this guy, then KEF LS50 Limited Black Edition. We got this guy, and so on and so on and so on. And now let's try to check the prices as well. So, you know, like this sort of an action I'm doing now. I've been doing this really countless number of times during writing, debugging, and fine-tuning this sort of a scraper. So we got this call and 2200s and 22,700. Oh my god, 22750. Let's drop it like that. And then we got this 69951150. Then we got call and empty. Okay, then we got call 1400, call 6750, call 1400, call 6750. So this is it. And now let me just try to quickly demonstrate you this. Let's try to get this image, the second one. So I just want to grab this sort of an image here. So just copy the image. So now we're supposed to see this sort of image because it regards to the second element here. And let me just try to paste this in. Okay, we got this image, perfect. And now let's try to check this sort of an image is for where we have more than one image. So let's take this Totem Acoustic monitors with the 1395 price. 1395, this one. So this Totem Acoustic, yeah, Totem Acoustic. Okay, and we got exactly 2 URLs here, perfect. So let's try to have a look at these URLs just to make sure that they have been extracted correctly. And alright guys, if this still seems quite pretty like piece of cake to you, please try to scrape this data on your own, and you would realize that this is incredibly difficult, and it only seems to be easy. It's like seemingly easy, but while on the real deal it's incredibly hard to scrape the data from this sort of a site. So we got the first image, okay, and the first image, so this one, and also this should be the second image. I've been checking this data manually to make sure that it kind of works perfectly well. Well, even though still I don't claim it doesn't have any bugs. You might have found some, but again, it's just the challenge, like proof of concept. It's not really a production, so I'm not gonna selling this or trying to get paid for this. So just as a proof of concept. Okay, so I need a browser, and here just try to paste the second one. Okay, so this is the second image. The second image matches exactly the same. Well, this is it, guys. We walked through the entire source code. I've shown you the results, and to me personally, this looks like to be absolutely fantastic. And you know, like when Andy just mailed me this challenge first, I think like this is impossible challenge. Like, so I've never seen such sacrilegious HTML markup ever. But still, through the couple of days, suddenly I've came up with this sort of a solution. And you know, like, I believe that you've never used the CSS absolute coordinates as the source of a mapper for the data on the target website. I believe you've never faced this sort of a stuff before. And Andy asked me, like many of you guys like to say or to ask, and especially Dr. Pi really loves that, to say like, man, you're taking the rabbit out of the hat again and again and again. So Andy asked me to take this rabbit out of the hat one more time, and I hope that this sort of a challenge solution might be recognized as exactly like taking the rabbit out of the hat one more time. But I hope this is not the very last one. So thanks for watching, guys. I hope you've enjoyed this. I don't even can call this a tutorial. This sacrilegious web scraping challenge, the most sacrilegious web scraping challenge ever. And I really encourage you to try this yourselves again. So this is it from my side. If you have some interest in web scraping challenges like this, please feel free to send those to me, or just to leave a commentaries within below this video, and I would be happy to take a rabbit out of the hat one more time. So this is it from my side. Thanks for watching. Until the next time, and take care. Блин, как я начал по-английски шпарить, охренеть.